We're going to start talking about string processing today, which is to say, right, let's think back to what we did with strings when we were um, working in C. Well, what is a string fundamentally? It's an array of characters, okay? And then the convention is to, how do we know that we've hit the end of a string? Yeah, there's a null terminator, which in ASCII is the value 0, okay? And furthermore, how much data does it take to store one character, in ASCII anyway? It's an 8-bit thing, so 1 byte, okay? And um, it, yeah, so each character takes up a byte. That includes the null terminator, right? That would also take up a byte. And then we just encode it in order, right? So if we have hello world or whatever, then that'll just get encoded, and then we can do stuff with it if we know where the string starts in memory, right? So if we have the pointer to it, then we know what to do, or we know where to get it. And then what we do with that string, well, that's up to us, right? So we'll start with just a kind of a simple computation in the sense of, well, how do I know what the length of a string is? Okay. Now the string.h, if you include that, there is a built-in C function called string length. I think it's strlen, right? And if you pass it a pointer to a string, it will tell you the length of the string excluding the null terminator, right? So if it says the length is 12, then you of course have to remember that it really takes up 13 bytes because you got to have the null terminator so you know where the thing ends, okay? Okay, so basically what I'd like to do is for us to write such a function, okay, today. All right, so to get started, let's, well, let me get the syntax highlighting to the correct assembly language. And in the process, we'll also talk a little bit more about this whole breadcrumb system. I want to kind of get a little bit more into it there. Because when we talk about recursion here in assembly, which I suppose we could do that Tuesday, maybe would make sense to start doing that. The breadcrumb system is really how recursion is going to work fundamentally. So yeah. Okay, so what are our core instructions? We need to store the stack pointer in the link register. Um, to put those onto the stack, and then we need to pop them off the stack at the end. Okay, so this is the usual thing, and then we need to move 0 to W0 so that we can return. Okay, so that's our shell. And in the data section, let me just add a string here, and it doesn't have to be anything in particular. Okay, so I don't have to put in, some of you guys have noticed that if you put in a \0, that is the encoding for the null terminator in the same way that \n is the shorthand for a new line or something along those lines. I don't have to actually put that in here because I use the data type ASCIZ, and so the assembler is going to put that null terminator in for me, right? So I don't have to worry about it. That's what the Z stands for, is 0, meaning null terminated, okay? Okay, so I've got my hello world thing, and I could put a carriage return in it, like a \n, if I wanted to print this and have it end up on a new line or something. But for just this instant, I don't really care about that. I'm maybe not going to print it, or actually, maybe we will print it. And what I'd like to do is compute the length of it, okay? Now, just looking at it, what is the length of it? So I see 13 characters, not counting the null terminator, right? So hello and world are 5 each. The comma, the space, and the exclamation mark is then 3 more, right? So this thing should take up 14 bytes in memory 13 for the characters, and then the null terminator is that 14th byte. Okay, good. Okay, so let's just print it actually real quick. And so if I'm going to print something, let me do this. Okay, so let me create a string here, and I'll say the length of %s is %i, and I want to kind of set us up for later where we'll compute the length of the string, and then print it along with the string itself. Okay, seem reasonable? Yeah. Okay, so if I want to do something with the string, okay, I'm going to do this in a function, which means I'm going to come down here and I'm going to have a new function which I'm going to call string length. Okay, um, and I want this to genuinely be a function. Okay, which means it must obey the calling convention, and as a function, it's sort of independent from the main program, meaning that I could write some other program that calls this string length function, but doesn't use the main part. Okay, does that make sense? All right, now I could put this in a separate .asm file. I don't have to, but I certainly can. I'll just put it here for sake of convenience today. Okay. All right. So if it's to be a function, what's the first and last thing that it must do? The store pair stuff. Okay. Now, it is not the case that in every instance of a function that you guys write, you have to have that. Okay. But for reasons that will become more clear later, just shut up and do it. Okay. And you don't want to do it, kind of willy-nilly, but if you're thinking of making a function, have the store pair load pair stuff, okay, in general. Okay. The last thing, of course, that we need to have is the return, basically to return from the subroutine back to where we were called by whoever called us. In our case today, that'll be the main function, but it doesn't have to be, right? Subroutines can call each other, as we saw in C, right? Like when you guys did um, the tetrahedron assignment, right? You had the tetrahedron area function or surface area function, and it called, in that case, 4 instances of the triangle area function, right? So main called surface area, which called the other thing, right? So you can go all the wrap turtles all the way down or whatever. Yeah. Okay. So got that. Now, what do I want to pass to my string length function, and what information should come back? Okay. So the way I want to think about this is if I were writing it in C, I would be writing it like this. Um, I'd be writing something like that, right? So what information do I need to pass to this uh, function? A string, but I can't really pass the string. So what really am I passing? I'm passing the pointer to the string, okay, a memory address. And then what information should come out of this function? An integer, right? A number. If I'm going to be counting up the number of things in it, well, then I should return an integer. Okay, so for me to call the function, where must I have to pass this function the pointer to the string. Well, where must the pointer be placed in order to obey the calling convention? It's got to be in a register, so which one? X0, okay? And it's X, not W, because memory addresses are how big? 64-bit, right? That's 64-bit architecture. Now, the integer that I return after I've computed it should be what? Where should that go? Again, got to be in a register. It must be returned in W0. Okay, so what's the calling convention again? Where do you put parameters that you're passing either to or from functions? Where do they have to go? Starting in X or W0, okay? And returning starting in X or W0. That gets you up to, what, 8 of them? If you need more, then you have to do some funky stuff with the stack, which we'll talk about later. Okay, so our function, in order to obey the calling convention, should expect that the pointer to the string comes in register X0, and that when all is said and done, we need to put the answer, which is the length of it or whatever we're computing, also into X0 or W0 in this case, because we're going to do an int rather than a long int. Okay, so is that okay? All right, so to set ourselves up for that, for the moment, let me just do this. Let me just move 0 into W0, okay? And so right now, my function would always return the length 0. Now, clearly, that's not what I want eventually, okay? But it'll be good enough to get the printing part working. Okay, so let's come up here and get the printing part working. So what do I need to do in order to print this this print string thing? Well, I need to do what now? I need to branch to printf, okay, because I'm printing formatted data. But what else do I need to do to set up the call to printf? Well, what's the format string I'm giving it? What's the name of it? I called it print string, right? That's my formatting string. So I have to give the printing function some information about this formatting string. And where's that going to go? X0, okay? So what am I passing to it? Oops. The address of print string, right? I have to give it a pointer. Huh? No. That will go in X1, as we'll see in a second. Okay? So the format string is print string. The hello world string I called my string. Okay, whatever. I mean, those are just names. Okay, but X0 has to get the address of the formatting string, and then in the formatting string, what am I printing? The length of %s is %i. What is a %s object? It's a string, right? Well, which string do I want to plop in that position in the format thing? My string, okay. And so that's the first percent character thing that we ran into. So what do I have to put in X1? The address of my string. Okay, and then what do I need to put in W2? What eventually has to end up there? The returned value from my function, okay? Which right now, let me just hard code that to be 17. Or no, how about let's do 1832. Okay, whatever. Okay, now obviously the string's length is not 1832, right? So I'm just card coding that number sort of as a temporary thing, and we'll go back and replace it later. Okay, so this should set up the printing, and it should say the length of hello world is 1832. Okay, good. All right, so let's make sure that it actually does that. All right, so I'll go ahead and assemble it with the debugging stuff just so we can use GDB later. Oops, what did I mess up? Oh, forgot an S. There we go. Okay. Typing is hard. Okay. All right, so what do we get? The length of hello world is 1832. Great. Okay, so the printing part is working. The only thing we'll need to change is to make sure that whatever number our string length function returns, we make sure that it ends up in W2 because that's where printf expects it. Yes? Oui? No. All right. So, okay, so as for the string length function, we need to call it here, right, before the printing. Okay. Again, what information do I need to pass to that function? What do I need to give my string length function for it to be able to do stuff? Well, I'm giving it a string, right? Okay, so how do I give it a string? I can't give it a string, but what I can give is the pointer to the string. Well, not as bad as Tuesday, man, but still.
My phone was dead. No alarm this morning, but luckily I had my great moment of waking up.
I don't want to know how he woke you up, but
You know, I woke me up. My calling me. He was saying, "Oh, are you not having class?" And oh,
yeah, well, you know, we invented these things called electrical outlets that you can plug your phone in to charge it.
I bought it, and it's just not effective. That's why we charge it.
You know, man, if you find yourself in a hole, what's the first step?
Wait, you mean like this?
Yes.
Oh, I thought you were meaning like the wireless thing.
No, like you plug that into that, and you plug the other end into your phone, and magic happens.
I thought I plugged it in last night, but I woke up this morning with no alarm almost dead.
Okay. Yeah, well, all right. So where were we before we were so rudely interrupted? I got to pass the pointer to the string. And where do I have to put said pointer? It must go in X0 because that's the first register and that's the calling convention. All right, so I need to put the address to my string here, and then I need to branch and link to, what did I call the function? String length? Then I would need to branch and link to string length, okay? When I come back from string length, the answer, the number, is in which register? 0, okay? W0. Where do I need it in order to do the printing correctly? W2. So what I should do is I should move it from W0 to W2, and then I can delete that line, okay? Now, notice, of course, I had to do this instruction before I loaded X0 and X1, because otherwise I'm going to nuke the data that I just computed, okay? All right, so if I run this now, what's it going to say the length is? It should say 0, okay, because my string length function right now is hard-coded to return 0, okay? Now, obviously, we're going to change that, but right now it's just returning 0, okay? So pointer goes in X0, answer comes out in this case W0 because it's a 32-bit number, not a 64-bit number. Right? I could have done a 64-bit long int. There's no, for counting the length of things, it doesn't really matter. But as we're going to see in a minute, there are situations where you want to use W's even though X's would suffice. Okay. Okay. So I've got everything set up, and now we just need to actually do the string processing. Okay. Which is to say, I need to get characters from the string and count them, right? And basically set up like a while loop kind of construction to count how many things there are. So I need to initialize a counter, I need to set up some sort of looping construct, and then off we go. Okay, good. So before we do that, the looping construct and stuff, let's just figure out how the heck do I get a single character into a register, okay, in order to be able to process it. Now, a character, right, is an 8-bit quantity, and that does fit into a register, and with room to spare, okay? All right, so how many of you guys got something from Amazon within the last, say, week or so? Yes? Okay, you got something from Amazon within the last week. What did you get? A flash drive. Okay, how big was said flash drive physically? Right? Tiny, like it would fit between your two hands, right, in its packaging. Okay. How big was the box or the container that Amazon shipped it to you in? Okay, so it was reasonably sized for the contents of the package, would you say? Relatively? Okay, but how many of you guys have had the experience where you order something that's like tiny, like, the size of a pencil or something from Amazon, and it comes in this ludicrously oversized box? Okay, have you had that experience? And you get that, and you're like, seriously, what are they doing? Like, why would they send me this tiny thing in this ludicrous box with like crap loads of the plastic filled with air or bubbles or peanuts or something like that? And you're like, really, what were they doing here? Okay, so the reason I mention this is that I want to think about the choice of W versus X registers as kind of being similar, right? If you've got something that will fit comfortably into a W register, why would you use an X register to contain it? Even though, I mean, they kind of are the same thing, right? So what you would like for Amazon to do is, of course, choose the smallest package size that reasonably accommodates. Man, you outdid men this morning. Mm. You guys with your alarms. This is like 3 failures due to alarms. Uh, Seems like we need to add this to like freshman orientation. Phone charging 101, and then like alarm setting 102, and you know, well, the first step is you turn off the lights and you put your phone away and you get in the bed, right? That's they don't tell you that. Well, I also don't tell you how to wipe your butt after you poop. So, okay, that was too much information, but yeah, because you probably have a bidet, don't you? Mm, yeah. Okay, we're going to stop this conversation now. Yeah. Yeah, I hope you're all awake now. That's lovely. Um, okay. Um, I would hope not, right? I would, yeah, no, okay. Back to strings, shall we? Right. Okay, so a character will fit into a register, right? Because a character is only a byte long. And kind of for technical reasons, well, how do I load something into a register from memory? Well, I need to do something like this. Okay, so what that will do is it will load 32 bits worth of stuff that's pointed to by X0 into the register W1, right? So this is that indirect reference. But do I want to load in 32 bits worth of stuff? No, I only want to load in 8 bits worth of stuff. That's a character, right? And so the instruction is not LDR, but rather LDRB for load byte. So that will only take 1 byte worth of stuff rather than all 32 bits worth of stuff. Okay, so it's slightly different instruction, but I'm loading a byte, so hence the B. Okay, is that okay? Okay, so what this will do is the capital H from our hello world, its ASCII value will be in W1. Okay, that's a number, right? What is the ASCII value for capital H? Does anybody happen to have their ASCII table handy? Um, look up what the hex value for capital H is off the table. Okay, so that number, whatever it is, will be in W0. Okay, now, 48, then that's hex. Yeah, okay, so 48 hex, right, which is not 48, but because it's really, whatever. Okay, 48 hex, good. Okay, so yeah, because it's really what, 72 decimal? Yeah. Okay. Right. Now, in our case, what do we care about with that value? It happened to be 48 hex. But what do I care about for the purposes of my string length program? That it's there and that it's not what? Okay, end of line, or we don't have an end of line in this string. How do we know we've hit the end of the string? The null terminator, right? So as long as the thing I just loaded in is not 0, then I'm Gucci, right? Okay, so if it is 0, then I know I've hit my null terminator and I'm finished. If it isn't 0, then I need to go up and, check the next character and the next character and so on. Okay, does that make sense? Okay, so what do I need here in order to count the characters? Well, I need something to be a counter, right? Um, and in C, right, I'd say like int I equals 0, and then maybe set up like a while loop or a for loop or something along those lines. Okay, so I need a counter. Where should I put said counter? Okay, W0 would be a logical place because that's where it needs to be at the end. Okay. If I'm going to do that, though, what's in X0 when the program starts? The pointer, right? So what about if I just move what's in X0 to X1? Would that be a good idea? And that way I still have my pointer, I'm just moving it to a different register. Okay, so I'll change this to X1 and I'm going to change this to X2. Okay, what should I put in register X, or well, W0 now? Uh, let's go ahead and use that as our counter, right? So I need to initialize the counter, and I need to initialize it with the value 0 because, well, before I start counting anything, then I haven't counted anything. Yeah? We know. Okay. All right. So got the counter initialized, and then okay, humor me here that I'm going to do an X instead of a W. That'll become a little bit important later, and I'll talk about why in just a second. Okay, so what does my loop needs to start here? Okay, I need to pull in the first character, and then I need to ask, is this 0 or not? Okay, is it the null terminator or not? Okay, and so if it is, then I'll just go to the end, and let me delete that because we've already got the counter set up. So if it is, I will just go to the end instruction, and otherwise I'll go back and loop again. Okay, good. All right, so how do I compare this thing that's in W2? That's my character. Okay, how do I compare that? What do I want to compare it to? What do I want to check? I want to check and see if it's 0, right? Okay, so how could I do a comparison to do that, right? Or what what should I type next? CMP W2 comma 0, and then B dot something. In this case, it would be EQ to go to end. Okay, now that's 2 instructions, yes? I can do it with one single instruction, and I will do that here just for sake of demonstration, with the instruction CBZ. Okay, so branching on, doing a comparison and branching on either 0 or not 0 is something that we do so commonly in programming that there's a special instruction for it. Okay, that gets it down to a single instruction rather than 2, which for efficiency reasons is a good thing. So CBZ, what do you think that stands for? Compare and branch on 0. Similarly, there's CBNZ, which is compare and branch on non-0. This case, we want to compare and branch if it's 0. Okay, good? Okay, so if the thing we just hit is the null terminator, we're finished. Go to here and we're done. Okay, otherwise, what do we do if we have not hit the null terminator? Well, what do I need to do to my counter? I need to add 1 to it, right? Okay, so let's add, where did I put my counter? I put it in, well, X0, and I need to add 1 to that, right? So that's counter plus plus in C, right? Okay, then what? Go back to the loop and start over with the next character, okay? Not yet, okay, and which is what I was about to say. Okay, so right now, if we do this, it will go into an endless loop, okay? And the reason is here, X1, we put, what did we put there? The location of the string, right? And so really that's the location of the first character. Did I ever change X1 within my loop? No, I didn't, okay? And so what this would mean is every time I loop, I would pull that first character, see that it's non-zero, and keep counting, right? So I'd go into an endless loop. That is clearly not a good thing. Yes? Okay, so I've got 2 options here. I can either increment X1 also, okay, and how much should I increment it by? 1, okay, why 1? The next character, and so 1 there is how many bytes I'm moving. Yes? Okay, so I'm moving over by 1 byte each time. Okay, so if I add a line there that increments x1 by also by 1, then I'd move over to the next character in the array. Okay, now I know it's plus 1 there because we're dealing with characters, and again, how many characters, or sorry, how many bytes or bits does it take to store a single character? 8 bits, right? 1 byte. Now, what about if I was dealing with an array of integers? Well, how many bytes does it take to store a single integer? 32 bits, so 4 bytes, right? So then I would need to increment by 4 each time, rather than by 1 each time, because that's how wide those numbers are. Okay. All right. So let's go ahead and just do it that way. Let's also add x1 with 1. And now we will no longer go into this endless loop. Okay. So what will happen is if the character is non-zero, we'll add 1 to the pointer so that it now points to the second character in the array or string, and then the third and the fourth and so on until such time as we hit the null terminator. Okay, good. All right, so let's hope that this works and let's test it and see what survey says. Oh, right. Okay. Remember, I can't. Oh, I'm sorry. What did I forget here? Duh. Right. I have to say what I'm adding to what. What am I adding to x0? The number 1, and where am I putting the answer? Back into x0. Okay, so I forgot that part of the syntax. Okay. All right. So, and let me just get that new line there so it will stop yelling at me. What? Oh, because I didn't save it because I'm a moron. There we go. Sure. To the main function. Yeah. Okay. So what did we get? The length of hello world is 13. Is that correct? I think so, right? Because how many letters? We said there were 10 letters and 3 punctuation. Well, 10 letters, a comma, a space, and an exclamation mark, right? So that's 13. So it really takes up how many bytes in memory? 14, because we have to keep in mind the null terminator that is present. Okay, but the length of it is 13 in terms of the number of characters. Okay, so does that make sense? We or no? Okay, so what questions do we have? Okay, yes. Where in the function? Well, we also use W2, right? Um, okay, so the reason, well, first off, did I really need more than, say, 3 registers to do all of this? Strictly speaking, no. Okay, now you might have said, all right, let me use W4 for my counter and W5 for my something else, right? But so the reason that I was trying to be tight with my register usage here is I also still have to remember the calling convention, right? So the calling convention, let me go scroll down to the subroutine, right? Oops, need to be here, right? So the subroutine requires, if I'm to obey the calling convention, the string's address comes in x0, and the number that I'm passing back needs to be end up in W0, right? Or x0, either one. Okay, why is that the case? Why is it that the string's address has to come in x0, and the return value has to go in either x or W0? Why? That's the calling convention under Linux, right, with this architecture, right? So we're obeying the calling convention so that our function could be interoperable with every other function that anybody else has written for this, okay? Yeah, Mr. Kuhn, do we have something funny? Oh, okay. Thought maybe I'd either inadvertently made a joke or typed something really stupid up on the screen, okay? Okay, So, good question. You can't, in the sense that, well, what is W0? Half of X0. They physically are the same thing. So moving something from W0 to X0 is kind of a meaningless thing, okay? With one exception, because there is sign extension, but that won't be an issue here, okay? Um, so, um, that said, if I want to move something from, say, W0 to X1, well, that's not really compatible, is it? Like that doesn't really make sense. So what I would have to think about is that I'm moving it and saying what to do with those other 32 bits. Okay. Now this is where our cardboard box analogy sort of breaks down, because could I move something from a small cardboard box into a big cardboard box? Yeah, but really, yeah, the analogy is not perfect. Um, so yeah, now this is less of an issue with the integers, because, for example, if I want to store the number 1832, what did we say that was in hex? 728, I think it was. Okay, and so in terms of the data, the bits, it was just a crap load of zeros before you hit the 728. Well, what's another 32 bits worth of crap load of zeros, right? It doesn't really make a difference. Um, unless the number is negative, in which case that is a problem. Okay. Do we have that issue here because we're dealing with positives? No, everything's fine. Okay. Um, but where this will actually be important, this idea of extending or shrinking the number of bits to encode something, will come into play when we start talking about floating point. Okay, because you can't just willy-nilly convert a 32-bit floating point to a 64-bit floating point, right? There's actually more to it than you'd think. Okay, the floating point registers, by the way, are not X and W, but rather S and D, for single and double, and those are physically separate from the X's and the W's. They're in the floating point unit, which is a separate part of the processor. Okay, back in the day, the floating point stuff was literally a separate chip that was elsewhere on the main board of the computer. It wasn't part of the central processor. And not every computer even had one of these things. So if you go back to like the 486 or 386 or whatever, um, there was a difference between models that either did or did not have, well, I mean, let's go way back to say the 8086, right? The 8086, which was what was in, well, a sort of a variant of it in the original IBM PC, um, it you could buy this thing, and it had that processor, and it could only do integer stuff. And if you wanted to do floating point, you had to do that in software. Well, you know what's slow? Software. You know what's fast? Hardware. Okay. So if you were found yourself in an occupation under which you needed to do lots of floating point kind of computations, what you would buy is the 8087, which was the floating point coprocessor. And then you could do things in hardware, and it was much, much, much faster, right? So if you had bought a PC back then, uh, in order to do, oh, I don't know, let's say you were an engineer, or you're a math person or something along those lines, you would have got that coprocessor. Nowadays, those coprocessors are actually integrated into the main processor. There is no coprocessor, but that took years to for that to be the case. Okay, so right, the so what we did here, right, is we basically incremented our pointer, right? So if we think back to when we did this sort of thing in C, and I had something that was like star pointer plus one, and then that incremented the pointer by the size of the thing being pointed to. Well, what's the size of the thing that our pointer points to? Okay, and careful, this is a technical question. What is our pointer fundamentally pointing to? Okay, it's not technically pointing to a string, although we kind of think of it that way. What really is it pointing to? The first character of the string, right? But what is a string, right? What data type? In C, I type car, right? It's an array of characters. So the pointer is really pointing to a character, just happens to be the first one in the string. Okay. Now we think of it as pointing to the string because the string and its first character are kind of, I mean, they're in the same place, right? So where else would we point to? Okay. But it's of data type car. And so when I increment, how much am I incrementing by? This would be down in my loop. How much do I need to increment by? So the incrementing of the pointer is this line, line 32. The incrementing of my counter is the previous line. Okay. I added one. And actually, you know what? Now that I look at this, what should I have done here? I should have made this a W and this a W. Because what kind of number am I using for my counter? 32-bit, not 64-bit. Okay, I think I typed X because of something that I'm going to say in a second. I'll change it back for reasons that I'll explain in a moment. Okay, so the line 31 is incrementing my counter. Line 32 is incrementing my pointer. In this case, I'm adding one to both of them. Okay, makes sense to add one to my counter every time because I'm counting, well, how many cars are there? Okay, but why am I adding one to my pointer each time and not 4 or 8, say? Why am I only adding one to my pointer? Yeah, because how much data does each character require? 1 byte. So the next one is 1 byte further on. Okay. Now, if this were, like I said earlier, an array of integers, how many bytes does it take to store a 32-bit integer? Well, 4 bytes. And so there I would increment my pointers by 4s. If I were working with an array of 64-bit integers, long ints, then I would need to increment by 8s. Okay. Um, and, well, I could, there's nothing special about that, right? I could even increment by more than that. So, like the 128-bit arithmetic assignment, right? I could construct a struct, right, in C to be a 128-bit number as being sort of a group of two 64-bit numbers, right? And I could even think of having an array of such things, an array of structs. You can totally do that. In which case I would need to just increment by even more, knowing, and of course in advance, how much data each little chunk took. Okay, for characters it's a single byte, but for other things it might be more. Okay, good? All right, so let me change this a little bit to a different way of getting at the incrementing without getting at the incrementing. Okay, which is I can also do the following. Okay, I'm going to use my counter and only have one incrementer. Okay, but then right now, if I run this, okay, it'll go into an endless loop, right? Because I never incremented the memory address to look at. Because I just removed that incrementing part. Okay, but what I'm going to do is I'm going to add x0 into the bracket. Okay, so what that does, this is sort of double indirection. Okay, you guys are going to love this. Okay, so let me go back to our mailbox analogy, right? So my parents, right, they don't have a mailbox out front of their house. They have to go to the central mailbox area, right? And let's say they get a package from the postal service. Okay, so My dad opens up his mailbox, and what does he see inside? He sees a key that has a number on it, right? That corresponds to one of the big boxes that's down below, meant for holding things that won't fit into the regular mailboxes. So he sees, okay, I've got key number 5. So I'm going to pull it into mailbox number 5, or big box number 5, open it up, and there's my package. Okay? So this indirection, when I put a register here in brackets, is like that, right? He's not seeing, like, he's going and finding the package whose address is stored in his mailbox, right? So he goes to register X1, he sees what number is there, and then goes over to that corresponding mailbox, right? Okay. If there's a second register in the bracket, it means the following. So let's say I tell my father, or he goes and he opens up the box, and he sees that mailbox key number 5 is there. Okay. And I also tell him the number 3. Which mailbox should he open? 8. Okay. 5 plus 3. Okay. So when I have two things in brackets, I'm going to go to the mailbox number that's inside this register, offset by the value in that register. Okay. So if I told him, Dad, I want you to do an indirect offset mailbox access, he would go to the mailbox, find a number in it, go to this other mailbox, find a number in it, add those two together, and then the result would be the actual mailbox he opens. Okay. Now, does that sound pretty cray-cray? Huh? He'd probably just say, "Shut up and get off my lawn," right? I mean, actually, have any of you met my father? I don't think so. He occasionally is here in town, but um, salty old Marine. He is kind of the get off my lawn type, right? Um, and he is very vocal about his disagreements with certain companies. So, for example, to this day, he will not buy any clothing product produced or owned by the Levi Strauss company or any associated company. Why? Okay, that seems oddly specific, right? So Dockers khakis, right? That's owned by Levi Strauss. He will not, because in the 90s, the early 90s, Levi Strauss stopped donating and sponsoring the Boy Scouts of America because the Boy Scouts said you can't have gay scoutmasters. And so Levi Strauss said, okay, well, then we're not giving you money. And so then my dad said, okay, then I'm not buying your products. Flash forward 20 years, and the joke's on my dad, but yeah, he still won't buy Dockers to this day. He also has like, he really dislikes Ben and Jerry's because they make all these politically themed ice creams, and he's like, they should just shut up and make ice cream. Huh? That's precisely what they're doing. They're just right, like it's just ice cream, right? Like, and then also like if you're like he basically thinks that companies should stay out of politics, and it's like, well, okay, maybe, but the Citizens United v. Federal Election Commission says otherwise, and yeah. Anyway, so yes, so salty old Marine. Anyway, okay, so yes, the mailbox analogy is starting to get a little bit strained here. Okay, with this sort of double indirection kind of thing. Um, what's maybe the advantage of how I just did it as opposed to how I had it a minute ago? Huh? Yeah. Well, I've reduced the number of instructions here by two, one maybe. Right. It's a little bit tighter. Okay. Um, and yeah. So thinking of getting to things, with base plus offset is a way of thinking that used to be more important. It's not critical that we do it here, right? But I went ahead and did so just for sake of demonstration, and we'll do things like that again. Yeah. All right, line 29. Okay, so I want to load a byte into W2. That's the destination for the data, right? That's where I want the data to end up. Okay, is that part clear? Byte, right? I'm loading a single character, which is a byte worth of data, as opposed to 32 bits or something bigger. Okay, that's why I have to have the B there. Okay, because I'm loading a byte, only one byte. Okay, okay, is that cool? Okay, so that's the operation, the opcode. Okay, where is this byte going to end up? Well, it's got to go into a register. So which register did I choose to put it in? W2. Okay, whatever. That's where it is. Okay, so that's where the data will go, right? But I also need to know, well, where is the data coming from, right? It's coming from someplace in memory. Okay, so where is it coming from? I'm saying go to mailbox X1. The number inside is an address. Add the offset that's contained in X0 to it to get a new memory address. Go to that memory address. Okay, so memory address whose value is whatever X1 plus X0 is, that number is a mailbox number. Go to that number, open it up, and that's where your character is. Okay, now how do I know what the hell X1 and X0 and stuff are? Well, what is in X1 when I hit this? What did I pass to my function? The pointer to the first character. And I put that into X1. Okay, so X1 here, I'm thinking of being always the base address of the string. And X0 is playing two roles here. It's how many spots down from the base address I am, but that happens to be exactly the number I need to keep track of to count, right? So I've made my offset and my counter the same thing here, right? And so when we did this in C and you had something like string of I plus J, or like, let's say, well, yeah, I plus J or I plus 1 or I plus 2 or whatever, right? That's basically what I just did here, right? It's just that it looks all funky bunky because of there's X's and brackets and whatever, but we're in assembly, right? Which is shirt and tie programming, not shorts and Hawaiian shirt programming, which is Python. Okay. You like Python, right? Yeah. Okay. So yeah, programming in shorts and a Hawaiian shirt, right? While you're sitting on the beach and you have like a drink that has a little umbrella in it, right? Why we do that, I don't know. As if it's going to start raining and the drink might need to be protected from the. Like, who thought? You know what we ought to do? We ought to make little miniature paper umbrellas to put them in our drinks to make them look fancier. Like somebody clearly thought this up. Well, yes, but also like it's a stupid idea. We do, right? We do, right? It's kind of like how many of you guys have, well, maybe not all of you are of age, but Patrick, you're certainly of age by now, right? Have you ever gone to a place and gotten a Bloody Mary and you get a Bloody Mary, but there's like an entire like charcuterie plate sticking out of it, right? Because there's like a pickle and a slice of bacon and cheese and olives and yeah, okay. Yeah. So, well, I mean, using some liquid nitrogen to spice up an evening is maybe never a bad thing, but yeah. Okay. So, yeah, I mean, Python programming, right, is that casual kind of thing. You can do a lot of stuff and somebody else deals with the details for you. C programming is you're in khakis with a polo shirt tucked in and your belt at least matches your shoes, right? And you're not going to be one of those guys that has like black shoes and white socks. No, that is verboten. C programming, or I'm sorry, assembly programming is you're in a three-piece suit. Okay, you've got all the details perfect. And that's the point of this class is for you guys to learn the low level stuff. Okay. Okay. So let's sort of recap here then. What did we do um, to do this? Okay. What do I need to do to count characters? Well, I need to know where they are in memory. I need to look at each one and see, have I hit the null terminator or not yet? Okay, and if I haven't, then increment my counter and move on to the next letter. Otherwise, I'm finished and that's it. Okay, all right, now let's say that I want to change those characters. Okay, so have I actually changed the letters in my string? No. Okay, they were hello world, and all I was doing was reading from them and checking is it 0 or not. Okay, and that's fine for the string length. That's all I need to do. Okay, but let's think about what are some of the other programs that we've written that do involve modifying strings. Well, like what? The Caesarean cipher was a good example, right? You took in a string. In that case, you also took in a number, right? And you modified the character that was in the string, okay? So, for example, let me modify the character that's in the string, and I'm going to do it in kind of a silly manner, but I'll do it in a silly manner for sake of demonstration. Okay. Um, Julia, since you have your ASCII table handy, what is the ASCII value for capital W? And I'm picking this just not completely at random, but essentially at random, right? Capital W is 5-7. Okay. So what I'm going to do is I'm going to load W3 or W2 rather with 5-7. Okay. So I'm doing that after I did the comparison because I don't want to accidentally overwrite my null terminator. Okay. So W2 now has, instead of the character that came in, whatever it was, it has the capital W. And I'm going to store that character to where I found it. So if I loaded with LDRB, how do you think I store? STRB, and the syntax is the same. Okay, I want to store it in the same memory address as it came from. Okay, now I'm changing the letter when I do so. Right, so the very first letter, what does it come in as? It's a capital H, which what did we say that was? 4-8 in hex, right, or in ASCII? Okay, and I'm saying, okay, it comes in, I look at it, it's 4-8. Is that 0? No. Okay, so I'll change it. And I choose to change it by writing a capital W to that spot. Okay, so what's going to happen when I print the string when all's said and done? What do you think? It's going to turn the string into all W's. And furthermore, how many all W's? How many W's will there be? 13 of them because I'm not messing with the null terminator, right? I don't want to make my string like suddenly become 3 times bigger. Okay, doing so is very dangerous, by the way. That can lead to things called buffer overflows, which maybe we'll talk about much later. Okay, so all I'm doing now is with that one extra instruction, well, two, I guess, right? Move and then store, is overwriting the string with each character with a W. Okay. Now, is that particularly useful to do? Like, would I ever want to do this in practice? Probably not, right? Overriding everything with a bunch of W's is maybe a little silly, but okay, I did it. Okay, now I want to point out one other thing here. And actually, before I go to that, any questions about the two new instructions, which are these two? Okay, so move W257, that was just loading the ASCII value for the capital W. And then the STRB stores a byte. It kind of goes with the LDRB, which loads a byte. Okay, is that all right? Oui? No. Yes. So 0x57, right? What is 0x57? That's a hexadecimal, it's a value in hex, right? The 0x tells me it's in hex. 57, where did 57 come from? It's what he looked up on the ASCII table. He said, oh, capital W is 0x57 in ASCII, right? So Y57, that just happened to be where it was in ASCII. Now, what about if I wanted lowercase w? It would have been 7, right? And actually, you should have known that because they're off all the uppers and the lowers are off by 20 hex, which is 32 decimal. Okay. Okay. So you notice that pattern? Isn't that wild? There's 26 letters, but there's other things in between, right? Yeah, okay. So no, somebody was very smart when they did that, right? The difference between upper low and lowercase is a single bit, which is that was smart, very smart. Okay, so Y57, I essentially picked it out of thin air, right? It happened to correspond to an ASCII value, and since I'm working with strings and characters, it makes sense. I have to think in ASCII. But this could have been something else, or in fact, this could have been something that's variable, right? Where I did some math to figure out what I'm going to put there. A good example of that would be, well, in the Caesarean cipher, how did that work, right? You looked at a letter, and then you looked at whatever the number your offset was, and you added to that, and then made sure that you didn't wrap around, you wrapped around at the end of the alphabet if necessary, okay? But you were modifying the characters, yes? Okay, so let me go into GDB because I want to point out something really important as to what we've just done. Space is 20 on the ASCII table. Yeah, so there is an ASCII character for the space. Okay, and it's not 00. It's 2. It happens to be 20. So look on the table; it should be there. Yeah, SP stands for space. Yeah, yeah. So in fact, all of them that are below 20, so going up from 00 to 1F, that 32 of them, those are non-printable ASCII characters, right? So the carriage return, the new line, the bell, the null terminator, there's a bunch of other ones in there, right? The bell actually used to refer to a real bell that would ding if you printed that character. That seems particularly appropriate here. Maybe not at every college, but yeah. Okay, so let me go into GDB because I want to point out something really important about what we have just done. Okay, I called this one strings 3. Oops. I think I forgot to recompile. So hold on, let me do that real quick. Okay. Okay. So where is the string happen to be in memory? Okay, it happens to be 48A048. Okay, whatever, right? So what I want to do is I want to go to that location in memory. Okay, let me just say this. You know what really fucking annoys teachers? When you guys all start packing up 5 minutes before class ends. Okay, so just hold your effing horses. Now, my guys in my 11 o'clock class on Wednesdays, I get it. They want to get in line for chicken tenders before everybody else. But, like, the chicken tenders ain't going anywhere. Just hold your horses. Okay. Oops. I didn't need to put a space there. Okay, so what happens to be in memory at that starting address? Well, what is all of that? Hello world, right? Okay, at memory address 48A048. Okay, whatever, that's just where the operating system put us. Okay, good. All right, let me run or continue the program, and I'm just going to let it run. Okay, and since I'm looping, it's going to take a while. And in fact, in order to speed this up, let me go back to main and let me do breakpoint on line 20. Okay, so it just ran everything until it hit line 20, which is just before the program is about to finish. Okay, all right, so it has now printed the length of blah, 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 blah is 13. Okay, we changed all the characters to all W's. Yes? Okay, so what I want to do then is let's go back into memory and let's look at what we had. What have we done to that string? We made it all W's. Okay, is the string "Hello World" in memory anymore? No, we have destroyed it by overwriting it with a bunch of W's. Okay, so what about if we wanted to do something a little like in the Caesarean cipher program, right? You printed the original string, and then you also printed the encrypted string. What would you have to do here? We'd need to make a copy of one of the strings, right? Because we've destroyed the original, right? So if we want to modify it but not destroy the original, we need to have two strings, one of which happens to be a copy of the other. Okay, does that make sense? Right? Because otherwise, I can't print. I don't have the original string left to work with. I've destroyed that information. Okay. Okay. So does that make sense? Right. Now that would be important. It didn't matter for this program. Okay, because all I was deliberately trying to do was overwrite it with W's just for the sake of demonstration. Okay, but I could need to worry about that. Okay, so what kind of assignment could I give you guys based on this? What would be awesome? Yeah, we could do a Caesarean cipher. Okay, now that said, what made the Caesarean cipher complicated? Yeah, the whole looping around the alphabet back to the beginning part, right? So you had to do some the percent operator, right? The modulus thing. Okay, and that there was a little bit of math there. A slightly simpler version would be what about if I have a string and I want to convert all the lowercase letters to uppercase or vice versa, right? That's a little simpler because the math isn't as hard, but the premise is basically the same. Okay. Or Patrick, what would be really fun? You no? Yeah, never mind. Okay, that's probably good for today. I will see you guys on Tuesday.